Hey everyone, welcome back. In the last video we switched out the Sequelize ORM for Prisma 2. In this video we're going to give our project a little bit more structure. We're going to worry a little bit more about our typing, and we're also going to pay a little bit more attention to the Apollo server way of doing things. We're going to configure our data sources and use a special package from Apollo called Apollo DataSource to create our APIs. Specifically for this video, we're going to create the user API and the project API, both based on our user and project model, or each based on our user and project models respectively. So in your code, if you could first, in your SRC folder, create another folder called Data Sources. And in that folder, add two files. One will be user.ts and the other will be project.ts. Right, and the data sources folder, it holds our API files. Our user.ts is our user API. Our project.ts is our project API. And to create these APIs, we're going to extend a class called DataSource, and that comes from a package called Apollo DataSource. So let's install that now. Okay, and now that we have that, we can bring that into our user API. And again, it's just called data source. So we'll create a class, a custom class called user API, and we'll extend the data source class. All right, we'll build a constructor. We'll construct a constructor, as it were. And our constructor is going to need the Prisma client, right? And we'll pass that in as a value called store. We'll also need the constructor from our parent class, the data source class, so we'll call super. And then we'll add the store property to this class. Alright, so first we get an error from TypeScript saying that our binding element store implicitly has an any type. Now Prisma Client is a very important third-party package that we're using in our project, and we're trusting it, so I don't really see the harm here in just casting this as any for now. Right, and then it says here store. Alright, the property doesn't exist on our user API, which is the class we're building now. So if you go to Quick Fix and you just declare the property, that fixes it. Again, store is just any. We don't need to worry too much about it right now. Okay, and also our data source package, it has a function called initialize, and if you just hit I, it should bring that right up. Right, and this takes a parameter called config. Alright, so immediately we see that TypeScript is complaining about the type. You could quick fix it. For example, infer parameter types from usage, and then we get an any. But let's go a little bit deeper with this. Let's not do it that way. Alright, first, what I'd like to do is start thinking about creating a bunch of different interfaces that we can use throughout our project, right? Basically reusable interfaces, and we can do that by putting them in a file called types.d.ts, and the d.ts extension means this is a types file, right? So that we can use them, the different types that we declare throughout our project. Right now, I realized that what I did was I added our user API code to the project.ts file, which was boneheaded. So put it in the user.ts if you made the same mistake as me. I hope you didn't. All right, so now to take a look at this config, right? This belongs to the initialize function, which belongs to our DataSource class, which comes from the Apollo DataSource package. So if we go into our node modules, to the Apollo DataSources, in the dist folder, you have a file called index.d.ts, and this is the file type, or sorry, the types for this package. So we declare the class DataSource, right, and that's what we're using, and we see that it has this initialize function with the config parameter being of type DataSource config tContext. So what we can do is we can just take this interface right here, copy it, and then put it into our types file. Now this is directly from Apollo, right? It's not one that we're creating ourselves, so let's make sure we let other people know that. So we'll say here, Apollo types. And then maybe after we're done declaring Apollo types, or not really declaring them, we're just pasting them in for reference so we don't have to go all the way to the node modules to see what's going on. We'll call these, the ones that we declare ourselves, project types. Okay, so in our user.ts file, we can declare this type after we import the data config. Data source config. Sorry, that's what we wanted to declare. Now it says here that right, it requires one type argument. So we could just say any, right, and do that. And if you look at your types, right, actually if we go back to index.d.ts, we see that the tContext is in any type right here, and that's what we'd be passing into our data source config. So rather than declaring or putting the any here, we can do this. We can go into our types file and say tContext equals any. And that works just as well. All right, and then we'll need our context. So the context for this API equals config.context. Right, and again, we don't have a context property on this API, so we can use quick fix and add it that way. You can see that it just added it here right under the store. All right, and then for now, we're just going to worry about getting the list of users that we've been getting and passing it through our GraphQL endpoint so that we can access the list at our GraphQL playground. So if you remember, if you recall, in our utils.ts file, we had a function called getUsers. So I'll go ahead and copy that and bring that into your user API. Paste it in. All right, we're inside of a class now. So we'll do that. Now our instance of Prisma is going to be store on this class. So let's do this dot store. That fixes that. Now if you see here, we're getting a value user from this list of users, or this result that we got from our find many query, right? But it implicitly has an any type, and if we do quick fix and we infer parameter types from usage, it gives us projects any. All right. Rather than doing that, why not just create our own user type according to our Prisma schema in our types file? So first, look at your Prisma schema, just to refresh your memory. So we're going to create a user type now. Don't worry about the password, we're not going to be returning that in this function anyway. So we'll need ID, name, email, and we'll also need a list of projects. And keep in mind that the projects are an array of project assignments. Let's actually close this, we don't need it anymore. Sorry. All right, in our types file, in our project types, we'll make an interface with lowercase u for user. All right, it'll have an ID, which remember is a string. It'll have a name, which is also a string, an email, which is also a string, and a list of projects, which is a list of project assignments. I keep saying list, but I mean array. Sorry, that's Python coming out there. All right, so why don't we also declare a project assignment, or make an interface for that. All right, and you remember this has a project ID, a user ID. Autocomplete kills you sometimes. I also should be a little bit more careful here. So the project ID was a number. It was an auto-incrementing integer. The user ID is the same as the ID for the user, so that's a string. All right, then there's a user, which is a user, and a project, which is a project. All right, so if you go back to your Prisma schema, right, you can see in your project assignment model, right, you have user and project as well as the user ID and the project ID. Okay, and then we'll declare also a project type. Has an ID, that's a number, has a title, and that is a string, has a status, which is also a string, and it has a list of members. Recall, the list of users for a project we decided to call members, so that's what we're going to call it. And those members are a list of, or an array of project assignments. Okay, so that should be good for now. If we go back to our user.ts file, we see that instead of using this, we can just say user, right? But of course, we have to import user from our types file. So everything's looking okay so far for our user API. Let's go ahead and do the same thing for our project API. So you can just basically copy everything here. Paste it into the project.ts file. And then just change what we need to change. Of course, we're going to change the name. That'll be project API. By the way, we should export our API here. So we'll need to do the same for our project API. All right, so we're still passing in the store the Prisma client. We're still going to use context. All right, we're still doing the same thing with initialize. All right, so what's changing here is our function. We're not getting a list of users, we're getting a list of projects. So we'll change this. And we're not using the user model, but the project model. All right, now we want to include the members, the project members. And we'll include user. Okay, and then all projects. So we're not mapping over a list of users, but a list of projects. All right, now we can say each project is of type user because we're importing it, but that's not really what we want to do. So bring in project from your types file. Change this. Okay, and then we're getting the basic values, basic properties of the user, or sorry, of the project. And then for the list of members, going to use the project model and map over the array of members. Okay, and then each assignment, recall, is of type project assignment. So it looks like we've typed everything okay here in this project API. Don't need this. Okay, good. So now let's go to our index.ts file. All right, this is our main file where we create an instance of our Apollo server and get it running. All right, we're going to need a few things here. All right, so we're going to need Prisma client. And the package was @Prisma client. All right, we're going to need our user API and our project API. So let's bring those in. All right, and now we want to create an instance of our store, right, which will use the Prisma client. It'll basically be the Prisma client, and it will get and add data, get data from and add data to our database. So we'll just call it store. You could call it Prisma if you like, but I'm just sticking with the Apollo documentation. All right, and then we're going to have to pass our data sources to our Apollo server. So one way we can do it is we can just make a function called data sources. All right, and that has both our user API, so we need to create an instance of that. All right, and to it we need to pass our Prisma client, which we're calling store. And then we'll also need our project API. or an instance of it. And we also need to pass the store to it. Okay, so into your Apollo server, you'll be passing still your type defs, your resolvers, and then after your resolvers, you're going to pass in your data sources. Okay, now one thing I'd like you to see is, for example, imagine you make a mistake here and you don't have data sources returning anything. Alright, that shouldn't be a problem right now anyway. But if you look down here at data sources, it says that type, and then you have here, a function that returns void is not assignable to this type where you have a function that returns a data sources object, or data sources with an object. So if you want to see where they're getting that from, you know, why TypeScript is being so strict about it, you can go to GraphQL Options, which is in the Node modules for Apollo Server Core. But if you just click on here, it'll open that up. And you can see that data sources is declared here. Right, so it has to be like this, right? You can't be returning void. And it also has here the data sources type that goes along with it. It's an interface for it. All right, but we didn't make that mistake, so we don't have to worry about it. We can just make sure that we return this object the way that we're supposed to. All right, and also one more thing we can do is, well, we're going to have to do it anyway, and I think I mentioned this already when we set up our user and project APIs. We're going to be dealing with a context, right? And a context is something that you can use to attach things like a JSON web token or a user ID or something, and that will maybe let you know the status of a logged in user. You know, it's something that gets passed to all your resolvers, and it can be used in each one to, you know, for authentication and authorization. But for now, we'll just go ahead and create a simple context. And it's actually going to take in the request here, and we can just give that a type of any for now. And for now, we can let it return null. We're not using it at this point, so that's fine. But since we're setting up our, you know, Apollo server a little bit differently now, we might as well pass in the context at this point. All right, and we're not getting any errors. Good. So on to our resolvers. And by the way, before we do that, there's one thing I'd like to do is, if you go into your schema file in your GraphQL folder, passing our password, you know, say to the Apollo, to the GraphQL playground isn't really a good idea, and we don't need to at this point. We can include the password property on, say, an authentication type or something else, but we don't need to include it with the user type. It's probably too risky at this point. So now go into your resolvers file. All right, we're no longer using get users from utils, right? We need to get this from our user API. Okay, so for our users function, in using Apollo server, we can pass in three basic parameters. Actually more than three, but for now we're just going to pass in the parent, the arguments, if there are any arguments to be passed in, which there aren't for the get users query, And then of course our data sources, and that'll allow us to access our APIs. So you can just use an underscore for the parent, a double underscore for the arguments, and then you can bring in the data sources as well. All right, so each one of these is giving you an error, a TypeScript error. So for these underscores, they're easy to solve. You can just put any. And again, we're just loosely typing at this point. So if something that really doesn't look, if you don't know what's going on and you put any, that's fine. But for data sources, we do know what's going on. All right, we know what our data sources should look like. All right, again, if we go back to that file that was in our node modules. It was in Apollo server core. It was GraphQL options, right? We need to have a data sources type that looks like this, right? It has an indexed name that's it can be passed in as a string. And also it needs to have a value for that property of a data source, which in our case is going to be either user API or project API. All right, so you can keep this for reference just for now. We'll delete it later, but go ahead and copy this, put it into your types file under Apollo types. All right, and then for our project type, let's go ahead and declare our data sources type and keep it in line with that. And we'll just call it data sources camel cased. All right, so our data sources object, or type, excuse me. Remember, it's going to have these two properties right here, right? User API and project API. Now, what is the user API? You could just say any, but again, that's going to end up hurting us. So what we want to do is we want to import user API, and I think VS Code will auto import it for us. So if we just type in user API, good, VS Code auto imported it for us. Right, and we can do the same thing for the project API. And again, it was auto imported. So going back to your resolvers file, for your data sources type, now import from types data sources. All right, and then we can give data sources that type. That makes the error go away. Good. All right, so we're almost there. We're almost ready to return our list of users, or we're to pass it through our GraphQL endpoint so that we can view them on our playground. So say const all users was await, and now we're going to use data sources. Remember, we're passing the Prisma client into data sources. So we'll use data sources dot, and we want the user API, and then we want the function get users. All right, we don't need to pass anything to that function. All right, and then once we get it, we can return it. All right, so if we run our dev server, and then we go to our GraphQL playground, we refresh, we're still putting in a user's query where we get the ID, the name, the email, as well as the projects associated with that user. Right, we get what we need, right? So everything's working fine. So our reconfiguration has gone well so far. Take a look at the query though. If we try to put in password, before it used to come up, but now if we type in password, nothing comes up. So we're no longer passing it. We no longer have it in our GraphQL schema, so we've made our project a little bit safer. All right, so back to your code. All right, we need one more query, and that's going to be for a list of projects. All right, so we can add that right under users. And basically, if we want to, we can just copy. Let's just go ahead and copy all of this down. And then we'll change the name to projects. All right, still our parent is going to be, we don't need to worry about it. Our arguments, there are none. Still using data sources, but now instead of the, well, here we'll call this all projects. We'll do the same here. Instead of using the user API, we'll use the project API. And we don't have a function called getUsers. We have a function called getProjects. Right, that's what we created in this file here. All right, there's one little thing that we need to do before we finish. For example, right now, if we go ahead and go to our GraphQL playground and we try to query projects, nothing comes up. Right, and you can see that we're getting an error here that query.projects is defined in resolvers but not in the schema. So that's a great error message. It tells us exactly what we didn't do. So if we go into our schema and we add one more query, and that will be a query called projects, and it will give us an array of projects. That should be good. All right, we see our error goes away. So let's go back to our GraphQL playground. Refresh. All right, we hit Shift space. We see we've got projects as a query now. All right, and then each project has an ID, a title, status, and a list of members. All right, and then each member has an ID, a name, an email, and we don't want to return the list of projects again. That would be ridiculous. Okay, so that should be good. So let's run our query. Okay, so excuse me. You can see here that we've got our list of projects, but for the members, right, we've got null here. And you can see that, for example, this first project, it has 2 members. It knows it has 2 members. It just doesn't have any information to give you. And it knows for the second project it has only 1 member. So let's go back to our code and go into our project API. So we mapped over a list of a list of members associated to a project, and for each project assignment we grabbed the project property, but that's not what we want. We want the user property. All right, so if we go back to our GraphQL playground and we run it one more time, we get the information for those users, right? So remember, Octavio belonged to 2 different projects and Farah belonged to 1. And then the third project had nobody assigned to it. So that's it. for this video, all we did was we reconfigured our project. We were a little bit stricter about typing, but not that much. We created a types file, so that helped us to keep track of the different types that we had and export those types to different parts of our project so that we could reuse them. We haven't really got into reusing them yet. Also, this was just here for informational purposes. You don't really need to keep it, right? But we are actually using this one here. Okay, so anyway, for this video we're all done, and in the next video we'll look at the context. We'll also look at our first mutation, which will be registering a new user and then being able to log that user in. So we'll also have to deal with authentication. So the next video will be a little bit more involved than this one for sure. Anyway, thank you very much for joining me as always, and I'll see you next time.